All right, question 5.4 says, you can also use the operator class in the quantum info module to simulate circuits and obtain a unitary. Given the following code, which option produces a different unitary from the rest? A different unitary, right? So first we're given this code to generate a circuit. So let's go ahead and implement that. Now this is the same circuit from question 5.2, and as before, here we also need from Qiskit import quantum circuit. And let's go ahead and also just draw that to see that is a Hadamard gate followed by a CNOT gate. So option 1 basically just generates the operator or the full matrix or the unitary for this circuit. So if we just copy and paste that, and actually let's do something here. Let's do import from Qiskit visualization import array to LaTeX, which as before is just to print this nicely. So let's do that here and see what we get. And here, as we can see, we get the full matrix for this quantum circuit, the unitary for that quantum circuit. Now let's take a look at option 2. So option 2, it's a bit of a long command. So how about we just break it into parts? So let's first just take this first part, which is operator from label and then this II. So what this is doing, sorry, I forgot to copy it. Let's go here, copy it again. So what this is doing is it's generating an operator which takes two labels, and what this is equivalent to is to tensoring two identity matrices. So if we do again array to LaTeX and print that, as we can see here, we have an identity matrix for 2 qubits. So it's like tensoring those two identity matrices. Now the next part of that command is .compose, and then it has an H gate and this this list here. So what the compose command or method from an operator does is it basically tensors whatever operator you have defined with what you're passing here. And what we're passing is a Hadamard gate, and we're saying, okay, apply that only to qubit 0. So what it's going to assume is that for qubit 1, we're just applying an identity. So let's go ahead and copy and paste that here. But as you can see, we don't have this H gate yet. So we have to actually import that. So we have to do from Qiskit circuit library import H gate. And I think that should run. So here what we need to make sure is that this parenthesis here is in the right place. So let's put this in the back here, and here we can see that now what we're doing is tensoring that identity matrix we had with a Hadamard gate and an identity where the Hadamard is being applied to qubit 1. So it's basically, you know, like having here at the beginning just an identity, and now we're like in this part of the circuit where we have apply a Hadamard gate. And then the last part of that command is another compose, so it's going to apply again. I said tensoring, but the compose is doing multiplication. It's matrix multiplication. And now what we have is a CX gate or a CNOT gate on between qubit 0 and qubit 1. So it's the same as applying a CNOT gate here. So if we now copy and paste that here, we have that full command that we had above. So first an identity, then a matrix multiplication with a Hadamard gate and an identity on qubit 1, and then a CX gate between qubit 0 and qubit 1. And if we run that, we get an error because I haven't imported this CX gate. So let's do that here. And here we have it. So you can see that these two matrices are the same. So option 1 and option 2 are giving us the same result. Now let's look at option 3. So option 3 is similar. It's defining an operator from a label, and as we saw before, it's doing it for a Halamar and an identity. So it's gonna be equivalent to just having this, right? So let's do that state by state again, and we do that, and we get that that multiplication or that tensoring of Halamar and identity. And then the next part of the command is adding an operator from label CX. But the problem with this is that these labels are gates for single qubits. This CX label does not exist. So what's going to happen is that this is going to throw an error. So let's go ahead and do that. Furthermore, we're doing an addition here when it should be multiplication, right? If we had the operator for Halamar identity, we would have to do matrix multiplication with the unitary for that CX gate. So if we do that here, then you can see here it just throws an error there. And then the last one is basically just defining that identity cross product with another identity and using compose of the quantum circuit, which, as we said before, this is just applying matrix multiplication, and this is generating the unitary for the quantum circuit we have defined. So we should be able to get the same total matrix or unitary that we had before. So here we see it same as we had here. So the answer is option 3, which has this error trying to use a label that does not exist.